And welcome back. As we continue our cosmic journey, we have, of course, taken a good look at the Earth, but now let's shift our focus a little bit to looking at the Moon, because this, of course, is going to have a lot of good relations with how we are perceiving our night sky here on Earth. And so we're going to do this with the phases and motions of the Moon. So one thing you might notice is that the Moon has a pretty changing appearance. Every night it might look a little bit different. After the sun, our moon is the brightest and most obvious object in our night sky. Unlike the sun, it does not shine under its own power, but merely glows with reflected sunlight. In fact, every time you see moonlight, it's actually just reflected sunlight. Now, if you were to follow the moon's progress in the sky for about a month, you would observe a cycle of phases with the moon starting dark and getting more and more illuminated by sunlight over the course of about 2 weeks. Now, after the moon's disk becomes fully bright, it actually begins to fade, returning to dark about 2 weeks later. So this, of course, is leading to us developing an idea of a cycle for the moon. These changes that we see with the moon fascinated and mystified many early cultures, produced marvelous stories and legends to explain the cycle of the moon. Now, of course, these were just stories, and we know a much more scientific reason today. Even in the modern world, though, many people don't understand what actually causes the phases. And they think, well, these phases somehow have to be related to the shadow of the Earth. And so the Earth is casting the shadow on the moon. So what we're going to do is actually see how these phases can be explained by the motion of the moon relative to the bright light source in the solar system, the sun. And so with lunar phases, although we know that the sun moves about 1/12 of its path around the sky each month, we can assume that the sun's light cycle comes from roughly the same direction during a 4-week lunar cycle. The moon, on the other hand, moves completely around the Earth in that same time. Now, as we watch the moon from our vantage point here on Earth, how much of its face we see illuminated by sunlight depends on the angle the sun makes with the moon. So, when we start looking at these phases of the moon, the appearance of the moon changes over the course of a complete monthly cycle. If we look at this image here, we can see pictures of the moon on the blue circles show the perspective from space. The outer images show you how the moon appears to you in the sky. So again, if you look here, here's our sunlight. You can see the sunlight is always coming from about the same direction. And so when we have a new moon, you can see the sunlight is hitting the moon right here. But when we look at the moon in the sky, because the moon is directly positioned between Earth and the sun, notice the Earth's not casting a shadow here on the moon. All right, here's the shadow side of the Earth. We got the sun. So we're actually, because the Earth is also receiving sunlight this time, and the moon part that would be receiving sunlight is in that same path, you can see we don't actually get to see the moon because it's not illuminated. And as we start moving around our lunar cycle here, you can see that the moon is, of course, receiving the light on that same position each time, but what changes is our perception of what we can actually see from our vantage point here on Earth. Now, if we look at this position new, as I mentioned, we are facing the moon from the right side of the Earth in the middle of the day. So at this point, we can't see the moon, and that's perfectly fine. Because as we start shifting here, we're going to see the moon start shifting its position throughout the day as well. So let's start off by first talking about that new moon, since that's a good starting point for lunar phases. The moon is said to be new when it is at the same general direction in the sky as the sun, which of course we indicate as position A. Now here in the new moon phase, it is illuminated, or this is the bright side. It's actually turned away from us and its dark side is turned toward us. Again, we can't see the moon because it's directly between the Earth and sun. In this phase, the moon is invisible to us. Its dark rocky surface does not give off any light of its own. Remember, the moonlight is just reflected sunlight. Now, because the new moon is in the same part of the sky as the sun, it rises at sunrise and sets at sunset. So that's why part of the reason why we don't see a new moon. But the moon does not remain in this phase for very long because it moves eastward each day in its monthly path around us. Since it takes about 30 days to orbit Earth and they're about 360 degrees in a circle, the moon will move approximately about 12 degrees in the sky each day, or about 24 times its own diameter. So from the new moon phase, we're moving into kind of a thin crescent. A day or two after the new phase, the thin crescent first appears as we begin to see a small part of the moon's illuminated hemisphere. The moon has now moved into a position where it now reflects just a little sunlight toward us along one side. The bright crescent increases in size on successive days as the moon moves farther and farther around the sky away from the direction of the sun, which we indicate in that image as position B. We call this phase the waxing crescent. And again, it's crescent because there's that thin sliver, and waxing just means to grow. Because the moon is moving eastward away from the sun, it rises later and later each day. From there, we move into the first quarter and additional waxing. About after 1 week, the moon is 1/4 of the way through its orbit, which, again, back to the original diagram, was position C, and so we can say it is at the first quarter phase. Now, half of the moon's illuminated side is visible to Earth observers. We can see about a half moon. Cool. Awesome. Well, because of its eastward motion, the moon, now lags about 1/4 of the day behind the sun, rising around noon and then setting around midnight. Now, during the week after the first quarter phase, we again see more of the moon's illuminated hemisphere, which, again, going back to the original diagram, would be position D. This phase is now called the waxing gibbous. From there, we have the full moon. And this is probably something you are probably familiar with the terminology of. Eventually, the moon arrives at position E in our figure, which of course is on the exact opposite side of the Earth. So it's now in that shadowed side, where it and the sun are opposite of each other in the sky. The Earth is now actually in the middle. Now note, while the moon's position may appear to be behind Earth, it's in that shadow region, the distance between the Earth and the moon is actually far enough away that its illumination is not blocked. So the sunlight is still able to hit the moon and reflect. Now the side of the moon turned toward the sun is also turned toward Earth, and so this is why we have a full phase. We can see the full moon during this time. Now when the moon is full, it is opposite the sun in the sky, which means, if you remember, the new moon came up during the day, which means with our full moon, the moon does opposite of our sun, which means it's going to rise at sunset and it's going to set at sunrise. So we're going to, of course, have the maximum full moon at midnight. Now, from there, we're going to move toward our third quarter and a waning expression. After leaving the full moon stage, the moon moves into the waning gibbous. So this is, of course, it's not quite a quarter, but we call it wane because now it's receiving. And so the shadow part of the moon starts to appear once more. About a week after the full moon, the moon is now at its third quarter, meaning that it's 3/4 of the way around. Not that it's 3/4 illuminated. This is a big distinction. The third quarter moon, it just means it's 3/4 through its journey. At this phase, the moon is now rising around midnight and setting around noon. The final stage before it returns to the new moon is known as a waning crescent. So we'll be back to that thin sliver that we kind of had when the new moon first changed into where we could see. Now, the moon's revolution and rotation does play an important factor into these phases. The moon has its own time periods. The moon's sidereal period, or the period of its revolution around the Earth, is a little over 27 days. A sidereal month for the moon is 27.3217 days to be exact, and the time in which phases repeat is a solar month, or 29.5306 days. Now, the difference results from Earth's motion around the sun, because the moon must make more than one complete turn around the moving Earth to get back to the exact same phase with respect to the sun. And as we saw, the moon changed its position on the celestial sphere rather rapidly. Now, the delay in moonrise from one day to the next, caused by this eastward motion, averages at roughly about 50 minutes. So let's look at this with the moon with and without rotation, just to really kind of demonstrate what this would mean. So the moon rotates on its axis at the same time it takes to revolve around the Earth. We refer to this as synchronous rotation. If the moon did not rotate as it ordered Earth, it would present all its sides to our view. Hence, the white arrow would point directly toward the Earth, only in the bottom position of this diagram. And that's, of course, what we're seeing here. You can see it's only pointing to Earth right here at the bottom. But because the moon rotates in the same period that it revolves, we always see the same side, which is the white arrow keep pointing toward the Earth. So we kind of have this tidally locked position of Earth. That's why you refer to, you might hear about like the dark side of the moon and stuff like that, because it's the side that's facing away from Earth. Doesn't mean that the side doesn't get illuminated, it simply just means that it's the side that we're unable to see.